Hello, and welcome to Edexcel Demola. And today's video, we've got something very, very difficult: organic synthesis. It's a difficult topic and it relies a lot on memorization. However, we're going to break it down, go through it, and hopefully get you some techniques that will help you to answer these questions when they come up in exam. So no time to waste, let's get into it.
Okay, so we're going to start things off by talking about our Quickfit Apparatus. And there's really only two that you need to know, and you just need to be able to draw this out and kind of explain what's going on. So, when we're using distillation conditions, as you can see here, what we're doing is we're starting with a round bottom flask. It can actually be pear-shaped, it doesn't really matter which one you use, but you apply heat to it. So whether this is a water bath, Bunsen burner, whatever, you just need to show that there's a heat source, and also there's a thermometer at the top. So what's really going to happen is you're going to heat up your substance and it's going to turn to its gas form. So these poorly written lines are gas, right? And it's going to come towards this bit, this vertical, well, kind of a diagonal bit going down, Now, you have water in and water out. So I'm just going to make that a bit more clear, Water in and water out. So what's happening, so I shouldn't have drawn that, but what's happening is you put your cooling water in and you can see the water is also going out. So going in at the bottom, out at the top. And what it's doing is it's cooling down the substance so that it condenses, And that's why we're in the Liebig condenser, So it condenses and it drips out into your conical flask, and that's how distillation happens. So you're getting your sample into the conical flask, Reflux conditions are a bit different. So what's happening in reflux conditions is we have a similar setup. So we have heat source, Bunsen burner, water bath, whatever. I've just drawn a pear-shaped flask this time, but it could also be round bottom. And what's happening is, it's going to go up. So there's a really long tube going up. But you can see the water's gone in, water's come out. It's going to condense and go back down. So you never actually get out. So it evaporates. So it doesn't allow any of the evaporation to allow your substance to get lost. It always comes right back in. So that's reflux and distillation conditions. So just think about what we did in previous lessons. Reflux conditions, for example, when you're using acidified potassium dichromate and you're going from an alcohol to a carboxylic acid, or you're going from a secondary alcohol to a ketone, reflux. Distillation conditions, let's say you're going from a primary alcohol to an aldehyde. So just know these are the two that we're talking about. Another important thing to address is separation techniques. So you can see here we have a separate and funnel technique. So we do this when we want to separate different layers of liquids, and it normally will be immiscible. So when we say immiscible, that just means that there's two distinct separate layers that don't mix, And your layers, or where the layers are, is dependent on the density. So we normally have an organic layer and an aqueous layer, So think about the density. The one that's lighter is going to be the layer on the top. So the one with the lower density is going to be the layer on the top. And then, for example, maybe your aqueous layer is just water. If your organic layer has a density less than water, so less than 1 gram per centimeter cubed, then it goes on the top. If not, it's at the bottom. And that's important because we need to know what is the desired product. So if a desired product is the organic layer and it's at the top, then you need to filter off, or you need to let the tap loose so you get rid of all of the bottom layer. And then now put the top layer into your test tube or your conical flask or whatever you're going to use. But just make sure you're making it clear that you're separating these layers. Yeah? Cool. So let's say you've got your desired product now. What we need to do is add a drying agent. So drying agents, I typically just go for anhydrous magnesium sulfate. I think this is easy to remember if you just stick to one. But anhydrous magnesium sulfate, calcium chloride, whatever, there'll probably be more. I think there's ammonium sulfate chloride as well. Whatever it is, just know that you're using a drying agent. And I typically just memorized one of them just so that it was really easy for me. Yep. Cool. So once you've had the drying agent, it should collect any of the excess water. And when you've got the excess water off with the drying agent, then you just do simple filtration. And once you've done that, drying agent gets caught as the residue, and the pure organic compound will be your filtrate. Happy days. Now, sometimes after that, we'll do redistillation, or we might just do redistillation to begin with. And this is when we have a mixture of organic liquids, Or we just want to make sure that our organic liquid is pure. Cool. What we do is we look in our textbooks and find the known boiling points, And when we have that known boiling point, we're going to heat it up to that level. And once it's at that level, then we know, because it's the same apparatus distillation that we just did, then we know this is the pure product. And that is that. So those are your separation techniques that you need to be aware of. Okay. synthetic routes, I was thinking of how do I go about teaching this? And unfortunately, a lot of it does come down to memorization and just practice and recall. So you can see here, you have this map. So I'm using the one from OCR, A-level chemistry. However, this is going to be the same for every single exam board. But what you can see here is we have a bunch of different organic compounds and we need to know how to go from one to the other. So the ones in red I've highlighted because for OCR at least, those are second year content. So you don't really need to worry about it for the purposes of this lesson. But essentially, something that they might ask, okay, say that I've got a haloalkane, how do I get to an aldehyde? So this is kind of how I do functional groups, look at them. Yeah. Start and target functional groups. So haloalkane, maybe it's a chloride, aldehyde will be that CHO. Yeah. Cool. Can it be done in one step? So looking from haloalkane, let's get our highlighter out. Looking at haloalkane, can we go to aldehyde in one step? No, we can't. So we need to use an intermediate. Okay. We need to form an alcohol. And again, I know you won't have this diagram in the exam, so you have to think about it, but you need to be able to recall what are the steps for me to get to where I want to go. Yeah? Intermediate required, well, easy. The alcohol is going to be the intermediate. A primary alcohol specifically is going to be the intermediate. And then you need to think reagents and conditions. So just thinking again, okay, well, for the haloalkane to the alcohol, I'm going to need sodium hydroxide, yeah, and heat. And then to get from the alcohol to the aldehyde, I'm going to need to do acidified potassium dichromate in distillation conditions. So you're just thinking like that. And again, it's just something that you need to keep practicing over time to help you out. So let's look at this example, for example. We're saying we want to go from this alkene, we want to go from that to a diol, yeah? An alcohol with two OH groups. So we've identified that. We're thinking, can this be done in one step? When I'm thinking from alkene, where can I go? I can go to an alcohol, yes, I can go to an alkane. What else can I go? I can go to a haloalkane. Yeah, so you're thinking, okay, there are multiple steps I can take, right? But in terms of getting to a diol, going straight to an alcohol isn't going to help me or put on one alcohol group. Maybe instead, what I can do is go to a dihaloalkane, and from a dihaloalkane, I can go to a diol. Yeah, that's what you need to be thinking about. And alkane will just add unnecessary steps, so we don't need to worry about that. So, in order to go to a dihaloalkane, basically you just need to add a halogen. I think bromine water makes the most sense, but you just need to add a halogen. Yeah, and then from there, what we can do is again sodium hydroxide, excess heat, and then you'll get your diol. So those are the steps that you need to think about. Yeah. I'm gonna just add a plus sign here because this isn't a catalyst. I know I've drawn it over the arrow, but this isn't a catalyst. But just make sure you're getting reagents and conditions down. And you can see those are the steps. So we form the intermediate in the middle. But you see we're going from alkene to alkyl. Yeah. Now, I can only stress you need to keep doing more and more questions of this to get it right. Because unfortunately, it is a lot of memorization and just knowing what the different routes that you can take are. Okay, so some questions to try. I'm just going to make it really clear what we're doing. So you have this question 2A, yeah? And it has two parts. So you're doing the part one, why does it use reflux? And in part two, about purifying an impure compound H from two layers, yeah? Okay. Then what we're looking at is also this question. So you're starting with that cycloalcohol, yeah? And you're forming a carbonyl, whatever that product will form, and then the structural isomers at the bottom. So pause the video, we'll give you some time and then we'll go into the answers. I'll just zoom fully out. Okay, so what we do for the first question is why do you use reflux? Well, the main thing is, as it says here, about we are preventing loss by evaporation. So remember, it's going to evaporate, but it's a really long column. So it's going to evaporate, and then because it's going through a long column for the condenser, it's going to condense before it gets out. So we don't need to worry about losing anything, and that allows your kind of reactions to kind of go to completion, pretty much. Now, in terms of how we would separate, well, you got to look at the question. Density was this, yeah? And I'm thinking, okay, they didn't tell me the density of the sodium carbonate, which is what we're comparing it to. So you would assume it's the same as water, which means that this is more dense than water, so it's the bottom layer. So once we figured out that, we're saying, okay, we're going to add a separating funnel. We're going to use the bottom layer because that was our desired product. And then drying with anhydrous salt, you can name it if you want. Calcium chloride again, so either or really. And then redistillation. So like we said, after you filtered it off, now we want to just make sure, is it completely pure? You would redistill, and it also goes to boiling point here. So remember those steps. That's really important because this is a fairly common question to come up in organic chemistry. Now we can quickly just go through here, to be honest. I would show you the answers, but I think we can kind of work out here. So in terms of a carbonyl compound, carbonyl means we have this. So realistically, the only thing we're going to get here is going to be a ketone. So you're just seeing here, you can see it's a ketone, yeah? So we're thinking, okay, well, let's draw it out. Bam, 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 bam. Get that there. So make sure you're using all the parts of the molecule and that. So again, I haven't drawn it on the best per se, but you can see all of the important things are there in the box. Yeah. Reagent, remember, you again, this is what I'm saying. A lot of practice is good, but there's going to be acidified potassium dichromate, ACR2O7, and then H plus. Yep, cool. Now, sodium bromide with an acid catalyst, you're thinking, oh wow, this is halogenation or addition of a halogen halide. Yeah. So when you do that, you do a substitution reaction. So this is going to get replaced by bromine. Simple as that. So again, drawing it out, making sure you get all parts of the molecule, and just replace it with the bromine. Okay. Acid catalyst and heat, you need to again think what is going on here. Well, if we have acid catalyst and heat to an alcohol, we get an alkene. So again, remembering those different pathways that we have. Now, the reason why it says structural isomers is because if we get the basis of the molecule, like here, bang, and then it's not here anymore. So the double bond can form on either side, really. So the double bond can form either here or it can form here. And the reason why they're isomers is because that's just different molecules. So for example, say we're going from the methyl group. This is carbon 1, 2, 3, and this is carbon 1, 2. So you can see they're different names, which is why you need multiple answers. But that is how you'd go about these questions. So like I said, unfortunately, a lot of it is memorization. But yeah. Okay, we're ready to wrap this up. So A-star tips. You need to be comfortable drawing out and listing the Quickfit apparatus. I'm not saying it's the most common question, but 100% definitely something they can ask and not something you want to be dropping marks on. So make sure you remember that. Distillation or reflux conditions, just know when they're being used. So, for example, distillation pretty much is only when you want to form an aldehyde from a primary alcohol. So just know that, really. And then the other ones are going to be reflux. And just know why we do reflux as well. That's important. Separating funnel, again, common practical question. I would make sure just to learn it. And then also the the synthetic routes, just make sure that you know them, yeah? Because the more you do questions, the more it will just become a bit natural to you. So make sure you keep practicing these. What not to do. Separating funnel and redistillation. So there are cases where you will just do redistillation, and there's cases where you do the separating funnel and then redistillation. Just remember both, yeah? And then also, not knowing when reflux conditions are used. So like we said, when we want a reaction to go to completion, we use reflux. And then also just so that we don't lose any of the product or any of the substance, yeah, because it's going to condense back down into the flask. Also, confusing synthetic routes, I'm not gonna lie, happens all the time. So just make sure you get really, really confident, and it almost becomes like a reflex. Like you see molecules, you're like, oh yeah, okay, I know where to go. So make sure you keep practicing your 1-step, 2-step mechanisms as well. And then reagents and conditions have always been easy marks to get. So just make sure that you know the reagents and conditions for the different reactions, because like I said, this is gonna be easy 1-2 marks here and there, depending on the question. So thank you so much for listening. I hope that's been really, really helpful. If it has been, please like and subscribe to the channel. Any questions at all, drop them in the comments below and I'll do my best to answer. We've also got a TikTok and an Instagram, both at demola. But that's all from me from now. So thank you so much for... Oh my goodness, I said it wrong. All from me for now. So yeah, thank you so much for listening. And we'll catch you in the next one. Bye for now.